Welcome back. In today's video, we will explore how to sketch the graph of a function and its inverse, and understand their unique relationship through examples and past paper style questions. Before we begin, make sure you are confident with sketching linear and quadratic graphs and understanding basic function notation. Let's do a recap of sketching the graph of linear function. Whenever we have to sketch a graph of linear function, then we have to take out x-intercept and y-intercept. For y-intercept, we take the value of x as 0. So in this case, when we will take the value of x as 0, we will get y is equal to -4. So the coordinates are 0, -4. For x-intercept, we will take the value of y as 0. So we will get the value of x as 4. So the coordinates are 4, 0. Let's mark these points on the grid and sketch the graph. 0, -4, we have -1, -2, -3, -4 here. 1, 2, 3, 4 here. So it is 4, 0. So we have one of the point here and another point is here. We can sketch a graph of linear function. Let's do the recap of sketching the graph of quadratic function. We have y is equal to x squared plus 2x minus 3. To sketch the graph of quadratic function, we can take out x-intercepts. We can take out y-intercept, turning point, and we can find out shape of the curve. By finding out the coefficient of x squared. If the coefficient of x squared is positive, means greater than 0, then the shape and the curve is a minimum curve. And if a is less than 0, then there is a maximum curve. So in this case, coefficient of x squared is 1, which is greater than 0. So we know that the shape of the curve is this one. Now we will take out turning point, x-intercepts and y-intercept. It's easy to take out y-intercept from this form of the equation. We have here -3. If we'll take x as 0, then we will be left with -3. So simply y-intercept is where y is equal to -3. So the coordinates are 0, -3. For x-intercepts, we have to take the value of y as 0. Now we can solve this quadratic equation by middle term breaking. X squared plus 3x minus x minus 3 is equal to 0. X is common, x plus 3. Minus 1 is common, x minus x plus 3. X minus 1, x plus 3 is equal to 0. So we have x is equal to 1 and x is equal to -3. Now we have to take out turning point. There are different ways to take out turning point. One is that you change this to completed square form. So when we will change it into completed square form, we will take x from here, we will take plus sign from here, we will divide the coefficient of x by 2. So we will get 1 here, we'll write it in bracket and whole square, then minus the square of this 1 and minus 3. So we have here x plus 1 whole square minus 4. When we will equate that x plus 1 to 0, we will get x is equal to minus 1. And when we will substitute minus 1 over here, then we will get y value as minus 4. So we have minus 1 comma minus 4, the coordinates of turning point. Another method is that we add the values of x-intercepts and we divide it by 2. We'll get here minus 1. And when we will substitute minus 1 in an expression, we will get the value of y as minus 4. The third way is that you use the formula x is equal to minus b upon 2a. So in this case, we have the value of b as 2 and the value of a as 1. So you will be getting minus 1 here. So when you will substitute minus 1 in this, you will be getting the value of y as minus 4. So you can take out the coordinates of turning point by any of the method which you find easier. Now we will mark these points on the grid and sketch the curve. 0 comma minus 3 is the y-intercept. So here is minus 3. 1 and minus 3 are the x-intercepts. So we can mark here 1, minus 1, minus 2, and minus 3. So these are the two x-intercepts. Then minus 1 comma minus 4. Here we have minus 4 and here we have minus 1. So minus 1 comma minus 4, there is a turning point. Now we can sketch the curve considering all these points. X is equal to minus 1 is the line of symmetry, as the graph of quadratic equation is a symmetrical curve. The coordinates here are minus 1 comma minus 4. The coordinates of y-intercept are 0 comma minus 3. The coordinates of x-intercept are 1 comma 0 and minus 3 comma 0. Some important points regarding the graph of inverse function. The graphs of f of x and f inverse of x are reflections of each other in the line y is equal to x. This is true for all one-to-one functions and their inverse functions. Why it is so? Because when we find out the composite function in which we substitute inverse function to original function is equal to x, if we substitute original function in inverse function, then also we get x. So both the graphs are reflections of each other in the line y is equal to x. Let's do some questions where we have to sketch the graphs of inverse function. We have f of x is equal to 4x minus 2 for x is greater than or equal to minus 3 and less than or equal to 3. On the same axis, sketch the graphs of y is equal to f of x and y is equal to f inverse of x, showing the coordinates of any points where the lines intersect the coordinate axis, means x-axis and y-axis. As it is a linear function, so first of all, take out y-intercept and x-intercept. For y-intercept, we have to take the value of x as 0. So y is equal to 4 into 0 minus 2, so which is minus 2. Then we have to take out x-intercept. X-intercept is when we substitute the value of y as 0. So the value of x is 1 upon 2 or 0.5. The range is from -1 till 3. We will substitute these values as well to find out the coordinates. So when we will substitute x as -1, then y value is -6. And when we will substitute x as 3, then y is 10. For the graph of f of x, we have coordinates 0, -2, 1/2, 0, -1, -6, and 3, 10. Now we'll mark these points on the graph and then we will sketch the graph. We have here -2, -4, -6. So it is 0, -2. Then we have 2 here, 4 here, 6, 8, and 10. And here we have -2, -4, -6, 2, 4, 6, 8, and 10. Remember, whenever you are drawing graph of f of x and f inverse of x on the same axis, then you have to take the same scale on both the axes. We have here y-intercept, x-intercept is 1/2, 0, which is to be here. -1, -6 is over here. 3, 10 is almost here. Now we will sketch a graph. We will draw a line passing through these points. We have to draw a line of y is equal to x as well. So we have 2, 2 here, 4, 4 here, 6, 6 here, -2, -2 here, -4, -4 here. Now we have to draw a line passing through these points. Now we will draw a graph of f inverse of x, for which we will switch the coordinates. X value will become y and y value will become x. -2, 0 is here. 0, 1/2 is here. -6, -1 is almost here. And 10, 3 is almost here. Now we will draw a line passing through these points. So this is the line of y is equal to x. This is of f of x. And this one is f inverse of x. This part of the graph is the reflection of this part. And this part is the reflection of this part. And they both meet at y is equal to x. Let's do another question. The function f is defined by f of x 3 minus x plus 1 whole square for x is greater than or equal to -1. Part A, explain why f has an inverse. As the domain is x is greater than or equal to -1, 3 minus x plus 1 whole square is a quadratic function. It is completed square form of the quadratic equation. If we equate x plus 1 to 0, we will get the value of x, which is at turning point. And when we substitute the value of x here as -1, then this will become 0 and we will be left with 3. So y is equal to 3 is the value at turning point. So the turning point coordinates are -1, 3. The value of x in the domain is greater than or equal to -1. So when you will sketch the curve of this, then you will get either side of the curve, which is greater than or equal to -1. If we'll consider just this part of the curve, it is a one-to-one function. So that's the reason its inverse exists. So we can write here f is one-to-one function for x is greater than or equal to -1. For this particular range, it is one-to-one. Otherwise, quadratic function is many-to-one. Find an expression for f inverse in terms of x. So we'll do the same steps. We will first write y is equal to 3 minus x plus 1 whole square. Then we'll switch x and y values. We have x here and we have y here. We will take minus y plus 1 whole square on this side. So it will become plus y plus 1 whole square is equal to 3 minus x. Now we can take square root on both sides. So this will become y plus 1 is equal to plus minus under root 3 minus. Now we'll take this 1 on other side. So it will become minus 1 plus minus under root 3 minus x. Now f inverse of x will become minus 1 plus under root 3 minus x. As the domain is x is greater than or equal to -1, so we just have to consider here plus sign. Part C, on the same axis, sketch the graphs of y is equal to fx and y is equal to f inverse of x, showing the coordinates of any points where the curve intersect the coordinate axis. We know the turning point is -1, 3. So you can mark this point on this grid. We have here -1, -2, -3, -4, -5, -6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and here -1, -2, -3, -4, -5, and -6. -1, 3 is over here. And we have to consider the values of x which are greater than -1. So we will take one of the value we can take as 0. We have equation y is equal to 3 minus x plus 1 whole square. So when we will substitute here 0, x as 0, then it will be 0 plus 1, it is 1, 1 square is 1, then 3 minus 1 is 2. So at 0, it is 2. We can take next value, that is 1. If we'll substitute here 1, 1 plus 1 is 2, and 2 square is 4, and 3 minus 4 is -1. So at 1, it is -1. Then we can take 2 here, 2 plus 1 is 3, 3 square is 9, and 3 minus 9 is -6. So it is 2, -6. These are the coordinates for f of x. So we can mark these points. 0, 2 is here. Then 1, minus 1, it's here. And 2, minus 6, it's almost here. We can take out the point where this curve cuts the x-axis. For that, we will take y as 0. If we'll take y as 0, then 3 minus x plus 1 whole square. So x plus 1 whole square is equal to 3. When we will take square root, so it is x plus 1 is equal to square root of 3. Then x is equal to under root 3 minus 1, which is 0.7. So 0.7 will be almost here. So when we will sketch a curve, it would be like this. Now we have to draw a line of y is equal to x, because whenever we have so we have this line y is equal to x. Now we will draw graph of f inverse of x. For f inverse of x, we will just switch these coordinates. X value will become y and y value will become x. So 3 minus 1, 2 0, minus 1 1, and minus 6 2. Here it was 0.7 0, and here it would be 0 0.7. Now we will mark these points. 3 minus 1 is almost here. Then 2 0, it's here. Then minus 1 1, it's over here. Then minus 6 2, it's almost here. And 0 0.7, which is almost over here. Now we'll sketch the graph passing through these points. So this is the graph of f inverse of x. This is the graph of f of x. Now we have to show the coordinates of any points where the curve intersects the coordinate axis. So this is the point which is 0, 2. This is 2, 0. This point is 0.7, 0. And this point is 0, 0.7. So whenever you are sketching the graph of function and its inverse, so you have to make sure that the scale is same on both the axes. Let's do a past paper question. The diagram shows the graph of a function y is equal to f of x. On the same axis, sketch the graph of y is equal to f inverse of x. As the graph of f of x is already drawn, we just have to find out the coordinates where there are whole numbers, and we will write here. This point is 0, -1. This point is 3, 1. And this point is 4, 3. 4, 3. Now for f inverse of x, you have to switch the x and y coordinates. So -1, 0, 1, 3, and 3, 4. We'll mark these points. -1, 0 is here. Then 1, 3, 1, and 3 is over here. And then 3, 4, which is here. First, you have to draw the line of y is equal to x, which will be passing through all these points where x and y values are same. Now we can draw the graph of f inverse of x. We'll join the points which we have already marked. So this is the graph of y is equal to f inverse of x. Let's do a quick recap. A function and its inverse are reflections in the line y is equal to x. Not all functions have inverses, only one-to-one functions do. To find the inverse, swap x and y, then solve for y. Always check domain restrictions when graphing inverse functions. If this helped you understand inverse graphs better, don't forget to like, comment, and subscribe for more helpful math videos. Keep practicing. Maths become clearer with every problem you solve. Thank you so much.